So going through some of the capabilities individually, and we'll use this vessel sort of as a little sample here for illustration purposes. When we look at the finite element model, Maestro uses a hierarchy to define the FE model because ship structures are fairly complicated. There's a lot going on in there. So we break the model down to make it a little more digestible in smaller pieces. Now the use of the like Rhino and other outside packages for generating your model has changed this a little bit. This is sort of geared more towards the original method that Maestro employed, which was to base your model on strakes. And if we look at this model, it can be broken down into substructures and modules, which are the sort of the different levels within the Maestro tree hierarchy. And in this overall ship, you can see we have just one substructure in here. And within that substructure are individual modules. So you have like one small module in here. And originally, because these were mainly built from drawings in the beginning, you didn't have the advantage of the existing 3D models. When you were building from drawing, you might go from one frame to another, and they would be built using strakes, where you could do straight line connections from one frame drawing to another, and you would basically build that entire strip of elements from essentially 2 lines. And that entire strip of elements, which is known as a strake, had various attributes, such as an embedded stiffener layout. You could easily change how many panels were along the length, as well as what the frames were and where they were located, and maybe a girder at one edge of the strake. And we'll see a better graphic of that later. But it allowed you to work on these individual modules one at a time and isolate them, so you could. It was much easier to get inside the model to add any detail and make any edits. If we look at just a single module here, and you can see the different types of elements that are represented, and they're all color-coded to make it a little easier for the user to identify. But they're all built up of some typical elements, quads, tries, beams, and rods in here. And the strakes make use of the longitudinal uniformity of the model. So you can see these red lines indicate some of the embedded stiffeners within each of these elements. And you can see we try and line them up. They don't really apply to the tries, but you can put them on both these light blue or individual quad elements, and these darker blue ones are strake quads, which are essentially the same quad element. It's just that it belongs to a strake. Now this is a sample of a strake that I was referring to. So it's essentially defined by 2 lines, one at each end, or one at each side rather, of the strake. And according at the module level, it's defined how many breaks there are along the length of it. But it has attributes such as the stiffener layout in here. So here you can see we have 4 stiffeners embedded in the plate going across. This yellow is a girder at the edge of the plate, or at the edge of the strake rather. So this is basically everything that's contained in that strake. So you've got the plating in dark blue. You've got the embedded stiffeners, which are the red lines. This yellow beam is the girder at the edge of the strake, and the red transverse beams are the frames. But it makes it nice and easy to define a fairly large chunk of the model in just one item in the Maestro model. And these are very handy for early stage design, where you may want to be varying your the number of stiffeners, the type of stiffener, since that's just an attribute of the element. And you don't have to, if you want to add a stiffener in there, you don't have to change the geometry at all. Maestro also has the ability to illustrate the hull girder properties graphically. And looking at this model, you can see, I guess, which elements are longitudinally effective. That's one of the attributes of the elements. You can tell Maestro whether or not that particular element is going to be longitudinally effective. So here you can see it's displaying all of the longitudinally effective structure in here, as well as you have the ability to also show things like inertia, cross-sectional area, neutral axis, and so forth. Here's a sample of the neutral axis. So you get the wireframe of the overall model and a plot of where exactly the neutral axis is on a section-by-section basis. And you can query each one of those plotted nodes to get more detailed information about it, as well as there's an output window. So you'll have a full listing of the data if you wanted to, say, grab it and export it into Excel or something for a table or another plot or something. Here's a sample of the motion or of the moment of inertia of the vessel. And this is a fairly common plot in Maestro where you've got the ship above, and it will show with some type of curve or graphic along the length, what the magnitude is of some value along the length of the ship. In this case, it's moment of inertia. It could also be something like longitudinal bending moment or vertical shear force or buoyancy.